how to do a titration calculation. So typically you'll be given the volume and the concentration of the alkali solution. In this case it's sodium hydroxide. You'll be given the concentration of hydrochloric acid or another acid, and you'll have to work out how much of that acid is needed to neutralise that much of the alkali, in this case the sodium hydroxide solution. You'll usually be given the equation, and in this case it's HCl plus NaOH goes to NaCl plus H2O. This is important because even though in chemistry we don't write the ones in, I'm going to put them there just to show, what this means is 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. So the first step is calculate the number of moles of sodium hydroxide that we used. And if we want to calculate the number of moles that we have in a solution, the formula that we use is N equals C times V. So remember that N is the number of moles, C is the concentration, and V is the volume, but we have to put the volume into decimeters cubed. So to convert 25 centimeters cubed into decimeters cubed, we need to divide 25 by 1,000. So if we put the numbers in, the number of the moles of sodium hydroxide that we have is the concentration, which is 0.2, and we're going to times that by the volume of the sodium hydroxide, which was 25, divided by 1,000 to put it into decimeters cubed, and the answer that we get is 0.005 moles. That means that we had 0.005 moles of sodium hydroxide in 25 centimeters cubed of sodium hydroxide with a concentration of 0.2 moles per decimeters cubed. Step 2 is state the number of moles of hydrochloric acid that we used. So because we're given the chemical equation, we know that 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid. And we know that because there's the invisible ones there that we don't write. So because the invisible ones that we don't write are there, 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid. So that means 0.005 moles of sodium hydroxide react with 0.005 moles of hydrochloric acid. 0.05 moles. So for the last step, it says calculate the volume of the hydrochloric acid that was needed. So remember, if you're calculating volumes or concentrations or number of moles of stuff in a solution, the equation that we need to use is N equals CV. But it says calculate the volume. So the volume is the number of moles divided by the concentration. And the number of moles that we have is 0.005 moles, which is this number here. The concentration we get from the question. So the concentration is 0.5 moles. So we're going to put that in below. Is 0.5. And the answer that we get is 0.01. Now, because we've converted things into decimeters cubed, the units of this answer are decimeters cubed. So it's 0.01 decimeters cubed. And since chemists and normal people tend to think of things in centimeters cubed, to go from decimeters cubed into centimeters cubed, we're going to times by 1,000. And 0.01 times by 1,000 gives us an answer of 10. And the units for this are centimeters cubed. So the answer to the question of the volume needed of 0.5 moles per decimeter cubed hydrochloric acid that's needed to neutralise 25 centimeters cubed is of 0.2 moles per decimeter cubed sodium hydroxide, is you need 10 centimeters cubed of that acid.